Today we're going to look at finding the area of circles and of sectors, and hopefully by the end of this video you'll be able to find the area of a circle, find the area of a sector, and to be able to work backwards from the area of a circle to find out a radius or diameter. So a few pieces of information to begin with. A sector is just a portion, a part of a circle. Think about a slice of pizza, think about a slice of cake, just something which cuts into the circle like that from the original, and that's a sector. And the radius is from the center of the circle to the outside, and the diameter is from the outside of the circle through the center to the other outside of the circle. We've got the formula for the area of a circle, which is pi times r squared. Pi is just a special number which connects the area of a circle to its radius. We don't need to know pi. We've got a button on the calculator that says pi, so we'll use that one. And if you want to find the area of a semicircle, because that's half a circle, it would just be half times pi r squared. And a quadrant, that's a quarter of a circle, that would be a quarter times pi r squared. So a semicircle and a quadrant, they're examples of sectors because it's just a piece of a circle, half a circle, a quarter of a circle. Any sort of fraction or percentage of a circle you can think of is a sector. Okay, so let's have a look at an example. We've got some information here and we want to find the area of this circle. So we've been given the diameter. The dot in the center shows you the center of the circle, and the line goes from the edge of the circle through the center to the other edge, so we notice the diameter, and we're given that it's 20. Now if we have a look at the formula for a circle, it's pi r squared. R is the radius and we've got the diameter. So the first thing we've got to do is we've got to half the diameter to find the radius, because the radius goes from the outside to the center, but then the diameter just doubles that distance because it goes from the outside to the center back to the outside again. And so we've got the radius being 10, and once we've got the radius as 10, we can just put it in our formula. So the formula says pi r squared. That means pi times r squared. And it's got a couple of lines of working there, but you don't actually need to show them. We can just type into our calculator pi times 10 squared all in one go and press equals. If it gives you some answer like 100 pi, you press the SD button and that'll turn it into a decimal. And then hopefully you can see that to one decimal place, it's 314.2. Now your calculator would say 314.159 and so on and so on. But rounding to one decimal place, it will be 0.2. Okay, so we'll look at another question. So here we've been given the area of the circle, and we want to find the radius and the diameter. So let's write out our formula again, pi r squared, and put in the information we know. So area equals pi r squared, and we know that the area is 50. So 50 equals pi r squared. And the thing we don't know is r. Pi looks like something we don't know, but it is just a number that our calculator knows, so that's not a problem. The only thing we don't know is the r. So if we knew what r was, then we would square it, times it by pi, and then we get the answer 50. So if we try to sort of undo those things, we'll get back to what r is. So divide by pi, and you got 50 divided by pi equals r squared. Then square root both sides because it's r squared. So if you want r on its own, you've got to square root it. So that is now something you can type into your calculator. the square root of 50 over pi, use the square root button, use the fraction button, use the pi button, press equals, press the SD button if you need to, and it should tell you that we've got 3.989 ... We put the ... in because it just carries on and on and on, and we don't want to write it all out. It says in the question, give your answer to the nearest centimeter. So to the nearest centimeter, that's 4. Then the next thing is the diameter. And the diameter is just double the radius. So you might think, well, let's just double the 4 to get 8. And you'd be lucky if you saw what you did, because it does give you the right answer, but you should be doubling the exact value of the radius. So doubling the 3.989 ... and then that rounds to 8. It won't always round to the same number. So you've got to be careful there, but in this case it would. And you've got a calculator, so there's no extra difficulty in doubling that number. Okay, so now let's have a look at sectors. So like I said before, sectors are like your fraction of a circle. So you can see in the diagram here, we've got just part of the circle is shaded in. You can see the dotted lines where the rest of the circle used to be. And that circle has got a radius, which is labeled R, and it's got an angle, which has got like a 0 with a line through it. That's the Greek letter theta. Okay, so that's just the same as if we wanted to use X or A or B or any other letter, but they're just using the Greek letter theta. That's what they normally do for this, so that's what we're going to do now. So if we think about it, what we had before was when we had a semicircle, it was half a circle, so it was half times pi r squared. When we had a quadrant, that was a quarter of a circle, so it was a quarter times pi r squared. However many degrees your sector is, if you put that over 360, the full circle, that's what fraction of a circle you've got, and that's what you've got to times by pi r squared. And then you get the area of the sector. So the pi r squared gives you the area of the whole circle, and then the fraction of the circle we've got, theta over 360, timesing it by that gives us the area of the sector. Let's have a look with an example. So we've got a sector here, and it's got 72 degrees as the angle and 6 as the radius. We want to know the area. So our formula says theta over 360 times pi r squared. Now, theta is the angle of our sector, so we can replace that with a 72. And the r is the radius, so we can replace that with a 6. So if I just replace those letters with numbers, I've got 72 over 360 times pi times 6 squared. So all that changed there was I changed the theta into 72, I changed the r into 6, and because I want to type it in my calculator, I put a times in there as well between the pi and the 6. So now it's ready to type in my calculator. If I type that in, then I'll get the answer all in one go. I don't need to work it out little by little. This is a calculator topic. And so if I type that into my calculator, press equals, press SD if necessary, then hopefully I should get the answer, 22.62 centimeters squared. And that's to 2 decimal places. So hopefully that has given us every piece of information we need to know to meet today's learning objectives, which are to find the area of a circle, find the area of a sector, and to use the area of a circle or a sector to work backwards and find a radius or a diameter. So that's everything that should help you do today's exercise, and if you need any help, just ask.